Alright guys, in this video we're going to take a look at similarity in right triangles. Now this is going to wrap up all of similarity, not as a review but kind of as an addendum. We're adding this on at the end of our similarity section because it's something that we should cover, so we will cover it, but we're going to keep it pretty simple, or as simple as we can get it. So what we're going to look at here today is we're going to look at what happens when I have a right triangle and I drop a perpendicular line down from the top. Now all of our triangles are going to look something like this, or it be kind of in this format of sorts. So notice what happens here. When I drop this perpendicular line, so I take this guy right here and I drop it down, it actually creates two more triangles. It creates a triangle here on the left side and a triangle here on the right side. And what ends up happening is you end up with a right triangle, the big one, broken up into two more additional smaller right triangles. So we have a large right triangle, we've got a medium-sized right triangle, and a small-sized right triangle. Now, these all have right angles, so that's one angle in common. And then notice that this angle right here, if we're thinking about the middle, the medium-sized triangle, and the big triangle, ABC, okay, so that's my big triangle, my medium triangle is ACD, okay? What I notice is that they share this angle. So they have a right angle and the shared angle in common, so that is going to end up being a similar triangle. We also know this little triangle and the big triangle have this angle over here in common, so they're also similar. So we end up finding out that when I take a right triangle and I drop a perpendicular line, I end up with three similar right triangles. Now, the way we solve these is still like before. We're still going to set up proportions, small side with small side, medium side with medium side, and so on. But what ends up happening is that when we set them up, we actually get a shared side. Because they're overlapping triangles, one of the sides gets shared. And you end up setting a proportion that looks something like this. Here's a side, small over medium, medium or small over medium, but that side is shared between two triangles. Now this is a little bit confusing, it's okay, but I do want to introduce you to this term. It's called geometric mean. Anytime we're doing a proportion, we're setting up two sets of x's together, or two of the similar figure in our proportions. That's called geometric mean. Now, that's not going to be a test question. I just want you to be aware that there is multiple different ways we can discuss mean. Mean is the average of things, but geometric mean actually is solved this way. Now, we're going to use this, we're going to use our usual proportions to solve a couple of different sets of sides. Now, we're going to look at these two triangles at a time. The first two we're going to look at is we're going to take a look at the smallest triangle and the medium triangle. So again, remember, we've got three triangles here. We've got a small, a medium triangle, and a large triangle. We're going to take a look at these two first, the small triangle and the medium triangle, and how we solve for sides between the small triangle and the medium triangle. So this is what we notice, okay? Actually, let me set it up. Well, this will work. Okay. So notice what we have. We have AD. Now this AD is what side of which triangle? Well, I can actually think about this as a separate triangle. Okay, so we're thinking about this triangle. On this triangle, I've got a small, medium, and large side, right? Well, this is the medium side. Okay, I'm just going to put M here. So I put medium side. This is the medium triangle, right? And I've got medium side of the medium triangle over, what do I have going on here on CD? Well, CD, again, we're thinking about this triangle right here. CD is the smallest side of that triangle. So this is the medium side over the small side. Okay, so that's my medium triangle. Now, we know similar triangles need to match up, smallest with smallest, medium with medium, and so on. So let's take a look at our small triangle. Now, notice what we have going on here. So I've got this small triangle here, right? Here's my small triangle. CD is the medium side of my small triangle. Okay, and that's my small triangle, right? the medium side of my small triangle over the smallest side of my small triangle. Okay, so medium over small, medium over small. And notice that the sides I'm using actually match up with the triangles I'm using. I'm using the medium triangle and the small triangle, the blue and the orange triangles. Those are my two. I'm not considering the big one. That's the whole thing. That tells me how to set up my proportion. I'm going to use the medium and small sides of my shape. So let's take a look and let's kind of set this thing up. So what we're going to do, now again, you can set this up two different ways. We kind of did medium side over small side. So we did the medium side of my medium triangle, 24, over the small side of my medium triangle, 16. Medium side of my small triangle, that's that shared CD side, over the small side of my smallest triangle. Okay, so does that make sense a little bit? All we're doing is medium side over small side on one triangle. We're going to look at the next triangle, medium side over small side. And then we would go ahead and solve this. So I get 24x is equal to 16 times 16, that's 256. I'm going to divide both sides by 24. And x, let's see if I can do this without a calculator, it's at least 10 point something. It's like 10.16, that's like a 10.6 or something like that. Let me just pull out a calculator and take a look and see exactly what exactly this comes out to be. So, sorry, I should have had my calculator ready here. So 256 divided by 24. 10.6 repeating. Okay, so I was right on the right track. All right, so 10.6 repeating. Now, let's check to make sure this makes sense. 10.6 repeating. Could that be that side? Well, it should be smaller than 16. It should be smaller than 24. So I'm okay with that as an answer. It doesn't have to look exactly right, but just make sure that it's smaller than what it should be smaller than. So that's the first kind, when I'm dealing with the smallest and medium triangles. Let's take a look at what happens when I'm dealing with the smallest and largest triangle. So once again, we've got three triangles here, small, medium, and large. And I'm going to take a look at my small triangle and my large triangle. Now, once again, okay, I've got my small side. We're going to do our small triangle first. Here's our large triangle. So the small side of my small triangle. CB, again, we're thinking about this triangle right here. CB, that is the long side, okay, the longest side, or the largest side of my smallest triangle. Now let's consider let's get rid of these guys. Now let's consider the whole triangle, okay? CB, that's the smallest side of my big triangle. AB is the largest side. And take a look, once again, the two triangles I'm dealing with, the smallest and the largest, also tell me which sides I'm going to set up. I'm going to set up the smallest sides with the largest sides. It works out really nicely. So let's solve another one. Okay, so smallest of the small, that's 4, over largest of the smallest, that's x, is equal to the smallest of the largest, so that's my x side again. Notice their geometric mean here. And then the largest side, now wait a second, BA, okay, they didn't give us the whole length here, though they could have. What we're going to have to do is we're going to have to do 4 plus 5, and that gets me to 9, okay? So that's going to be 9. Now, sometimes they'll give you the full length, so don't add it if they give you the full length. If they don't give you the full length, then you might have to add here. And then once again, we're just going to go ahead and solve this. So I get 36 is equal to x squared. Take the square root of both sides, and I get x is equal to 6. And that can be 6, right? Because it's smaller than my largest side, but it is bigger than this small side right here. All right, last one. We've looked at the small and the medium. We've looked at the small and the largest. Now let's take a look at the medium and the largest. And guess what? Our sides are going to match up exactly the way you might think they will. So we're going to look at our medium triangle here. This is my medium triangle. I'm going to do my medium side over my largest side. I'm going to look at my large triangle. I'm going to do my medium side over my large side. Same thing like before, okay? So let's go ahead and set this thing up. Okay, so once again, medium side of my medium triangle, 56 over 78. Now that 78 is the medium side of my big triangle, so 78 over AB. I'm just going to call this AB distance x. So that equal to x. and then I'm going to go ahead and solve this. And I'm not going to try and do that one in my head. 78 times 78, 6,084 is equal to 56x, and then let's divide that by 56, and I get x is equal to 108.6. 108.6, and that would be my distance here for x, 108.6. All right, so that wraps up each of the different types. Now we're going to try to keep this really simple. All of our triangles are going to stay in the same format, so you shouldn't have any differing. We're not going to twist them on you, flip them, anything like that. For the assignment, we're going to keep it pretty straightforward and simple. These are the three different things. The big thing that you need to ask yourself is which two triangles are in play. Am I dealing with smallest and medium, smallest and largest, medium and largest? If you can figure that out, you should be able to set this up no problem.